Before you write your first Java code, I would like to welcome you to this course and thank you for enrolling. In this lecture, I will give you a short summary of what will be covered in this section. So, in the next video, I will show you how to write a basic Java code. Then I will tell you what elements Java code has and how it builds up. After that, we will jump into the topic of variables and simple data types like numbers, text, and so on. I will also show you how to compare variables with expressions and how to run commands repeatedly with loops. After that, we will move on to control flows, which will help you to make decisions based on the variable values. Then the topic of methods will come. They help you to wrap commands that connect it to each other and makes the code reusable and more readable. And last, arrays. They help you to store many values in one single unit. Don't worry if some of the concepts are unknown for you. I will make it all clear in the upcoming lectures. So that's pretty much it. Let's write your first Java code. Before we move on to some coding, first of all, I would like to thank you for enrolling. I hope you enjoy the course and find it useful. If you do, I would like to ask you to leave a rating when you will see the following pop-up. Also, if you have some time, please write some words about what you think about the course. This enables me to continue providing more content and the best experience possible for you. Thank you in advance for your review and taking part in making the course better with more content. Have a great day. Okay, in this lecture, we are going to write your first Java program, but we are not going to go into very details now. It will be a simple program which will display a text on the screen. The goal of this lecture is to make sure that everything is installed correctly and you're going to be able to run the code is shown in the upcoming lectures. I suggest you code along now and I will make it all clear in the next video. So, JDK and Intellij are installed and we are in Intellij now. So here, click on New Project. Then select Java on the left if it is not selected. Up here you can see Amazon Corretto 15 or 11 or 8. It depends on which version you installed. And if you cannot see any of those, click on here and click on Add JDK. On Windows, you need to search for Amazon Corretto folder, and inside of it, JDK 11 or 15, and you have to select the folder and click on OK. You can also see the folders that you need to select for other operating systems here. I'm going to click on Cancel now, and there is nothing else we need to select here, so click on Next. On the next page, we have an option to create a project from a template. We will use this feature in the upcoming lectures, but we go the hard way now because I want to show you how to build a project from zero. So click on Next. So here you have to type in the name of the project. I suggest you to start every word of the project name with lowercase and separate the words with dashes. So like here, my dash first dash Java dash project or program. I also suggest you to put the projects into a new directory. For me, it is the complete Java course. And if you selected the folder and gave name to the project, click on Finish here. And then click on Create to create the folder for the project. Okay, so you should see the created project on the left. So click on this little arrow at the top here, and you can see a .idea folder at the top, which was generated by Intellij. Then a src or source folder, where we will create our Java files. There is also a myfirstjavaproject.iml, which was also generated by Intellij. To create our first Java file, right-click on the source folder, then New, and Java class. Now we need to name the class. In the name of the class, every single word starts with an uppercase. So like my first Java app. It is more like a business standard than a rule, so you can start with lowercase as well, but using this naming style shows that you have some sort of advanced knowledge in how Java files should be named. If we are finished, we need to hit enter. As you can see, Intellij has already generated a few lines of code for us. So public, class, my first Java app, and curly braces. As you can see, the file name and the text here, the class name, is the same. It is really important. Okay, so as I said, we are not going to go into very details now. We are just simply type in a code which will print out a text. So next, in the curly braces, hit enter just to create some space. And here start typing in public. And as you can see, Intellij is very handy. You don't need to type in all the letters. You can select the desired code from the list and hit enter. The next one is static. And enter again. Then void. And finally here, main. Now we need to add a left parentheses. And as you can see, Intellij added the right one as well, and in the parentheses string left square bracket, and as you can see the right one is added, and then a space and args, and after the parentheses we need to add a left curly brace, and the right one is added as well, and I'm going to hit enter here. Okay, so this whole line is a special function that shows to Java that the execution of the code should start from here. Okay, so one more line left from here. So start typing in system dot out dot println, which means print line. So we're going to print out a line, and in the parentheses, double quotes. And as you can see, another one is added as well. So in the double quotes, we have to type in the text we would like to print out. So I will type in, may the force be with you. Okay, so we are finished with coding. As you can see, there are green arrows on the left. It doesn't really matter which one you choose. Click on one of them and select the run option. Okay, the text we wrote in should appear at the bottom of the screen, which shows the console outputs. And under that, you can see the process finished with an exit code 0, which means everything went fine. Okay, so in the next lecture, I will explain all the elements presented here. If you run into an error, please check this video again. Maybe you missed something. But if you cannot figure out what went wrong, let me know and I will help you to resolve it. So that's it. See you in the next video. In this lecture, I will explain every single word in the code we wrote in the previous video. So this code is to display may the force be with you. Okay, so first we created a class, then we added the main method to it, and last we added a command that printed out this sentence. Now let's start with some main parts of the code. First of all, keywords. Java has many keywords. In Intellij, they are highlighted. With the style of Intellij, they are orange. They must be used in a specific order. Also, they are case sensitive. So public with lowercase doesn't equal to public starting with an uppercase. Okay, let's move from the top to the bottom. So public. Public is an access modifier which defines how other parts of the code can use this code block. Besides public, there are other access modifiers too, like private, protected, and package private. But more on this later. The next keyword is class keyword. It is just used to define a class. After that, the name of the class, which is the same as the name of the file. After the class name, curly braces defines the scope, the area, the territory of the class. All the code inside the curly braces belongs to the class. So just to summarize this, to define a class, you need to have an access modifier, which is optional, then the class keyword, which is mandatory, and finally the name of the class with the curly braces. Now let's move on to the main method. So what are methods? Methods are used to group together operations connected to each other. Methods also have a name, and by using that name, you can run the operations in that method from several different places. So it is a very good tool to make your code reusable. Also, they make your code more readable because the operations connected to each other grouped into one single unit. In other programming languages, methods may be called procedures or functions. Now let's move on to the main method. It is a special method. It is a starting point for running Java programs. So when you run your Java code, it starts from the main method and runs and uses code that is written here and used through other classes. So let's go into some details. Public, as I said, it is an access modifier. Static shows that this method belongs to the class rather than the object that you can create from this class. To understand this, first you need to know classes and objects and the difference between the two concepts. Don't worry, it is not rocket science. I will make it all clear later in the course. Now let's move on to the next keyword, void. Void means that this main method doesn't return anything, a number or text or something else. It simply runs an action, like here, a text is printed out to the screen. Okay, the next one is main, which is the name of the function. Then two parentheses, which shows Java that it is a function. And in the parentheses, there are parameters like here, string, square brackets, args. String, square brackets, which is an array, a list of text. And args is the name of that list. Here you can see how it would look like if we would store values in the args array. We use the name and then square brackets, then a number in the square brackets to get the element of this array. We will look more into this later in the arrays lectures. And last, the curly braces that belong to the main method, which shows the scope of the main method. So every comment between these curly braces belongs to the main method. Okay, so the last part of this code is the system.out.println and the text. So what is system, what is out, and what is println? System is an inbuilt class of Java, and it represents your computer system. Then out is a field, an attribute in system, which is responsible for the outputs. For example, to show something on the screen. And println or print line is a method or function of out. It prints out one single line. The parentheses show that this is a function and its parameter is the text we would like to print out between two double quotes. One last thing here is the semicolon at the end of the line. It is a must for every single command, but you don't have to use it at the definition of classes or methods. If you miss it, Java will warn you that the semicolon is missing from the end of the line. Let's give it a try. Now I'm going to delete this semicolon here, and let's run the code. And as you can see, a semicolon is missing from the end of the line, and Java expected a semicolon there. If you click somewhere else and you click on this error message here, the cursor will jump right to the place where the semicolon should be. And if I add a semicolon again, and I run the code again, you can see it is running again and we get 0 exit code. So what I suggest you to do here is to print out something else and also change the order of the keywords just to explore what error message you can get. Don't worry, you cannot do any harm, it is just code. You can always find the code of the lecture next to the lecture's title as a resource. Alright, that's it. See you in the next lecture. Before we move on to another topic, I would like to show you how you can get the source code of the lectures. To get all the source code of this course, you have to go to the public GitHub repository I shared in the course resources lecture in the introduction section. You can see that exact lecture on the right, and you can see the link here. If you click on the link, it will be opened in a new tab. Here you can see the same structure as the course has. So here, Advanced Beginner Intermediate currently. And if you go here, Code, and click on it, and then Download Zip. Here, Save File, and click on OK. Then open the file. Here, click on Extract All, and select the folder where you would like to extract it. I will stay with the given option, so click on Extract. Now let's go to Intellij. Here, File, Open, and go to the place where it was downloaded. So down here, Downloads, and here, Complete Java Course Masters, and select this one here and click on OK. Open project. Where would you like to open this project? This window, a new window, it doesn't really matter. I'm going to open it in a new window. You might see an error message at the bottom here. Don't worry about it. Just click on X, then click on Project up here. Then on this small arrow here, Source. And as you can see here, the course structure, we're going to go to Beginner, Your First Java Code, and double click on My First Java App. You can see some extra stuff here. So this package com.beginner.yourfirstjavacode, and it is the path to this file. You can see the same packages folders here as well. You can also see other packages for other lectures code. If you don't want to download all the code of this course, you can easily look into one single lecture source code. If you go to the lecture, and next to the lecture's title, here, you can see this resource button, and you will find a GitHub source code link if you click on it. It will direct you right to the file or folder where the lecture's code can be found. If you cannot import the project or one of the links doesn't work, let me know and I will help you to fix it. Alright, that's it. See you in the next lecture. In this lecture, I'm going to talk about variables. Okay, so what are variables? Variables are used to store information, something like a number, a letter, a sentence, or a combination of these. It is a piece of memory segment where the data is stored. First, we're going to look into the declaration and definition of a variable. So how to declare a variable and what it means. So to declare a variable in Java is the following. You need to type in the data type first, then the variable name and a semicolon to the end of the line. We don't assign any value to it here. Let me show you how it works in practice. So we created this program previously. Now let's delete the system.out.println line here. And instead type in int number of followers and a semicolon. This variable can represent the number of YouTube or Twitter followers, or we can use another name like number of countries. Int here is used for whole numbers. As you can see, the variable name is gray because it isn't used and it doesn't have a value. So how we assign a value to this variable? That's what is called definition. It is very simple. First the data type, then the variable name equals, and the value we would like to assign to the variable. And finally a semicolon to the end of the line. Or we can first declare the variable and then you type in the name and equals, the value and a semicolon. Okay, how it works in practice. I'm going to show you the second case here. So an enter here and number of followers. And Intellij offers us the variable name, enter, and then equals, and 195, and a semicolon here as well. The other option is to define it in one line. The easiest way to do that is to delete this here, and that's it. Both correct, but the second one is used when we don't know the value of the variable at the beginning, but we will calculate it later. Okay, so what data types Java has? There are two groups, primitives and object references. There are separate lectures to explain them in details, but I'm going to give you a short introduction to them here. So let's start with primitives. Whole number data types are byte, short, int, and long. They vary based on how big number they can store. Int here is bold because it is the default data type of whole numbers. They can be used to store whole numbers like number of players on the field or number of passengers. The next group is floating point numbers. There are two types, float and double. Here, double is the default value. They also varies based on how big and precise numbers they can store. They can be used to store bank account balance or transaction amount. The next group has only one type, Boolean, which can have two states, true or false. It is a simple one and a good option to store values like will it snow tomorrow, true or false. And the last one, which can be used to store one single character, char. It can be used for storing the energy efficiency category of a refrigerator or washing machine. Okay, now let's move on to object references. They are a bit different from the primitives. I mentioned in the introduction section that objects has a state or states and also have behaviors. Primitives doesn't have that kind of functionality that objects has. There are many object reference types and primitives has their object reference versions as well. So the whole numbers, byte, short, integer, and long. They are almost the same except that they are all start with uppercase, and instead of int, here we have integer. Uppercase here shows that these types are object reference types. And you will see all object types start with an uppercase. Okay, now let's move on to floating point numbers. Float and double. Nothing special here. Also, Boolean has its object reference version as well. What is new here is the text types. Instead of char, we have a character with uppercase, which can do the same thing, store a single character, and a new data type, string. String can store almost unlimited amount of text. It can be used to store sentences, descriptions, titles, basically any kind of text. The last group here is the built-in and custom object references. It can be a file writer, which can be used to modify a file or system that we used in the first Java program lecture. Then Blueware can be the name of a custom object in a game or an ATM machine for a banking system. So besides these inbuilt object reference data types, we can define our custom ones as well. In the upcoming videos, I'm going to show you how to use primitives, how to use object references, and how to define and use your own custom versions. But before that, I would like to tell you more about the naming conventions of variables. So variables are case sensitive. For example, if you would like to use a variable, you need to type in exactly the same name when you declared it. The next one is that typically variables cannot be declared two times with the same name in the same class or in the same method. Also, variable name must start with a letter or $mark or underscore, but I don't recommend you the last two. After the first letter, it can contain numbers, but it isn't recommended either. And last here, variable names cannot be equal to reserved keywords of Java. Here you can see a list of the reserved keywords: abstract, continue, for, new, switch, and the list goes on. You don't need to memorize these. Java will warn you that you cannot use these words as variable names. You might think this list is very long, but don't worry, I will explain all of them later in the course. One last thing I would like to share with you is the naming standards in business. These are not forced by Java, and it is not necessary to follow them, but they can make your code more readable if you stick to them. Also, if you apply for a job and you apply these recommendations, it will show the interviewers that you are familiar with the business naming conventions. The first point is Camel Case. So the variable name's first word should start with lowercase, and every other word in the variable name should start with uppercase, like I did with number of followers. Number lowercase, then of with uppercase, and followers with uppercase too. The next one is that the variable name should fully describe what the variable contains. So don't name the variables like X, Y, Z, or A, or B, or C. Instead, use meaningful names. If you go back to your code a week later, you will hardly remember what A, or B, or C means. The following point is that do not use abbreviations if you can avoid them. Use long variable names instead. Okay, the next recommendation is that do not reuse the variable names for other purposes. For example, do not use the number of followers variable to store number of notifications. Create another variable for that instead. And the last one, I mentioned before, do not use $sign or underscore in the variable names. Okay, that's pretty much it. See you in the next video where I will tell you more about primitives. In this lecture, I would like to introduce you primitives. First, we will go through the list of the primitives and what values we can store in them. Next, we will go to the website where I will show you where you can use these primitives. Then we will do a coding practice based on the website. And last, you will see how to convert one data type into another one and what pitfalls it might have. Okay, let's do it. So we have 4 groups of primitives: whole numbers, floating point numbers, Boolean, and character. Whole numbers are byte, short, int, and long. Byte can store values from -128 to 127. Short from almost negative 33,000 to almost 33,000. Int can store a little bit more than 2 billion in positive and negative. And long can store a massive number. The most commonly used is int, and the rest of them are barely used. But if you are restricted on memory, you use byte short if it's necessary, and if you need to store a huge number, use long. Okay, let's move on to floating point data types. There are float and double that you can use as variable data type. The difference between the two is that float can be precise until 6 to 7 decimal digits, and double until 15 decimal digits. Here, double is the more commonly used. There are 2 other primitive data types, Boolean and character, here char. Boolean is probably the most commonly used data type of all. It can have 2 values, true or false. The other type is char, which can store 1 single character or an ASCII code character. Don't worry if you don't know what ASCII means. I will tell you what it is and how to use it later. Okay, now let's move on to the website I mentioned before. Okay, so the website we're going to use as an example is mobile.de, and here are the details of a damaged 2018 Dodge Challenger SRT, and I'm going to show you what data types can be used to store these values. I'm going to think universal, so I will choose data types based on the idea that it could be any other car. Okay, just a side note before we started. Price is a whole number, and the comma here is just a separator. While in case of fuel consumption, it is a decimal point, and the points just separators for thousands. Okay, let's start it with numbers. So the price of this car can be stored in a short. Okay, but what happens if the car is more expensive? For example, it is a Ferrari. Then we need an integer. Do we need a long for this? No. I think it's very unlikely that a car can be more expensive than 2 billion if the prices are stored in euros. The next one is the mileage. Same situation here. Short is not enough for this, but an integer is good. The next one is power. Okay, so here is the time for using short. Byte would be too small for these numbers. An integer is an overkill because it is pretty unlikely to have a car with more than 32,000 horsepower or kilowatt. Cubic capacity can be stored in a short as well. Okay, moving on to fuel consumption. Here, float is far more than enough to do the job. Even if you are working in a lab, you don't need to know more than 6 to 7 digits. If they would need more precision, they would use double for these. Next, CO emission. I think short is enough. Number of seats. Well, it is a tough one. For a bus, it may need to be a short, but I think byte is enough. Door count is an absolute byte type. Emission sticker and number of vehicle owners can be stored in a byte as well. It is very unlikely that the number of owners will be over 127. Here, first registration and AGU are dates. We don't deal with them now. So two data types are not used here, Boolean and char. As you can see, it is a damaged car and there might be a variable called isDamaged, and the value of that variable is true for this car. And if that is true, the damaged, accident damaged vehicle text appears, but if it's not true, the text doesn't show up. And last, char. To be honest, we don't really use this. The last time I used this, well, it was 10 years ago before this recording, but I think you must know what it can be used for. So, for example, emission sticker may have other values like A, B, or C for different emission levels. So that can be one option to use char. The rest of the site is stored in string, we will cover that later, or static HTML text, which is not stored or used, but it is simply displayed. Alright, that's all about the website. Let's do some practice. Okay, so now we are back to Intellij and our code from the variables lecture. We have a list of data that we will use and create variables based on that. Alright, let's jump right into that. So let's start with bytes. Before that, delete the line we created in the last lecture, this one. So the first one was the number of seats, which was 5, I guess. So as I showed you in the variables lesson, data type, variable name equals value and a semicolon at the end of the line. So byte number of seats, and as you can see I'm using Camel Case here, equals 5 and a semicolon. So that's it. It is easy. Let's define other variables too. A tip, it is really easy to duplicate lines with Ctrl+D or on Mac Command+D, but you can use copy paste here too. Okay, 3 byte type attributes were on the site. So Ctrl+D and here number of doors. It was 3 and number of vehicle owners, which was 1, and emission sticker, changing the name, emission sticker, it was 4. Now let's move on to shorts. Only thing is changing here is the data type. So first short power equals 362 and a semicolon. You can use power or power in kilowatts as variable name. It is really up to you. The next one is horsepower, so doubling this line, horsepower with uppercase, and it was 492. Then CO2 emission. In case of CO2, we can use numbers in the variable name, but you can also use letters, so you can type in 2. It's really up to you again, both correct. So doubling this line, and here CO2 emission equals, and it was 333. And the last short here, cubic capacity. So doubling this line again, deleting this part, and it was 6,417. Okay, in int we had price and mileage. So here int price equals 29,999 and a semicolon, and doubling this line, mileage, and it was 14,999. That's it. Here we're going to add an extra thing. We are going to create a long for registration number. When you start creating long in the beginning is the same, so long registration number equals, and a lot of numbers and a semicolon. So when you're finished with adding some extra numbers and a semicolon, you realize that something is not okay. The problem here is that when you create a long, you have to add an L to the end. Uppercase or lowercase, you can use both, but I recommend you to use uppercase because lowercase l looks very similar to 1. So adding an L here will remove this red underline. That's it. So the reason why we have to add L to the long numbers will be explained later. For now, I can say that default data type for whole numbers is int, and for floating point numbers is double. In case of long and float, we have to tell Java the exact data type of the number. It's a bit simplified, but don't worry, I will make it all clear. So we are almost done. Let's define floating point numbers. So we have 3 float values: combined urban and extra urban fuel consumption. So here, float fuel consumption combined equals, and it was 15.5, and we have to add an F here and a semicolon. The next one is urban, so removing this combined and replacing with urban and changing the number to 21.4. And one more, the extra urban, so adding extra here and changing this value to 13.6. So as you can see, I changed the order of the words. The reason is that this way it is easier to read and see that the variables are connected to each other. Okay, I know we didn't have double on the website, but let's define one. It will store the precise average fuel consumption. So here, double fuel consumption precise average equals, and 15 points and a lot of random numbers and a semicolon. We can manipulate the number and define how many times we would like to multiply or divide it with 10. To do that, let's put an E and a number to the end of the number. So adding E1 and dividing the number with 10, so this way 1.5 will give us the same number. And doing it the opposite way, just adding a negative here, we still have the same number. Okay, now leave it as it is, just to prove that this works properly. Okay, just a side note, it works only with double and float. Now let's move on. Two more variables left. One is Boolean, is damaged. So here, Boolean is damaged equals true, and a char for energy efficiency category equals simple code. And in a simple code, well, Dodge Challenger is not the best in saving the environment, and I think the worst level is G, so I will give it a G here and a semicolon. Okay, so finally we defined all our variables, and as you can see, all of them are gray because they are not used anywhere, but it will change very soon. So in a new line here, start typing in system.out.println or use SOUT and hit enter. I'm going to go that way, so SOUT. And when prints a string to system.out appears and it is selected, hit enter. And now, as you can see, it is replaced with system.out.println. So double quotes here, 2018 Dodge Challenger SRT 392. So doubling this line, and instead of this text, let's replace it with price, colon, a space, and a euro mark. You can also add it to the end of the text. I will show you how. And here, after the double quotes, plus, and just type in the variable name price, and when it appears, hit enter. Okay, that's it. Now, as you can see, price is here and price here is not gray anymore. You can also add another text to the end of this by using plus again, double quotes, and you can type in euro if you cannot find the euro key on your keyboard. Okay, deleting this here, and now let's move on to the next one, which is mileage. So doubling this line again, and instead of price we're going to have mileage, and here mileage plus double quotes and kilometer or miles. It is really up to you. Okay, now the next line is damaged. So here the car is damaged, colon, and here instead of mileage and this text is damaged. Registration number and cubic capacity will be the next. So here registration number, and here registration number as variable name. Okay, now cubic capacity. So here cubic capacity, here cubic capacity, and plus double quotes and CCM. Now let's print out power and horsepower in the same line. So here power plus kilowatt, and a left parentheses, and here plus the horsepower plus double quotes and HP, and a right parentheses. Okay, CO2 emission is the next, so deleting this part here. CO2 emission and deleting this part of the code. Oops. CO2 emission plus and I is emission missing from there, and space and gram per kilometer. Now the emission sticker and the energy efficiency category, so doubling this line here again, and here emission sticker, and here left parentheses energy efficiency category, lowercase colon, and plus energy efficiency category plus, and double quotes and right parentheses. Also, let's add a space here too, and that's it. Okay, now let's move on to the next line here. So the fuel consumptions, so doubling this line, and here combined fuel consumption colon plus here fuel consumption combined, and deleting this part of the code, and here liter per 100 kilometers. The next three is going to be easy, so just simply doubling this line, and instead of combined we're going to use urban as word and changing the variable name here to urban, doubling this line here extra urban, and the text as well here. One more left. Precise average fuel consumption, and here changing this to precise average. So three more variables left to go: number of previous owners, number of doors, and number of seats. So here doubling these again, deleting this, number of previous owners, and here number of vehicle owners, doubling this line, number of doors, and finally number of seats. Okay, so now we are done. Let's go to the green arrow up here and select run. So now you can see all the variables and the text we just typed in as an output here. I know it was a bit long. Feel free to pause the video and take a break. In the next lecture, I will show you how to convert a data type into another one. See you there. Let's continue this lecture with conversions. So why we need conversion? Because sometimes the value in the variable is changing. You add up numbers or multiply them, or you need a smaller data type to be converted into another type. There are two types of conversion: widening and narrowing. Automatic or widening conversion is easy. Imagine variables as boxes. Byte is a small box, short is a bigger one. You can easily put the content of a smaller box into a bigger box. As we go along, it is easy to see why we can convert upwards. The other way is narrowing. Well, it is not too pleasant. We have to put the content of a bigger box into a smaller one. So here you can lose data, which can cause problems. So as when we go downwards, we have to use the following form. First, the desired data type, new variable name, equals the desired data type again in parentheses, then a value like 1000 or another variable name. We also call this type of conversion casting. I think it is easier to see how conversion works in practice if I show you some examples. So let's do some coding. So now we are back to Intellij, and first I will show you some examples of automatic conversion. As I mentioned previously, the number of seats as a byte is enough. So what happens if the company decides that they are going to sell buses too? They will have to use short instead of byte. Before the conversion part, let's print out a text just to separate the two code blocks. So here, system.out.println, double quotes, and here just a word, conversion. So we are going to need a short. Let's call it new number of seats. So here, short, new number of seats equals number of seats and a semicolon. Now let's print out this new number. So here in a new line, system.out.println, double quotes, the value of new number of seats, and here plus new number of seats. Let's convert another attribute of cars as well. For example, combined fuel consumption. Combined fuel consumption is stored as a float, but let's just say we need a more precise number. So we are going to store it in a double. So here in a new line, double, new fuel consumption combined equals fuel consumption combined and a semicolon. And in a new line, again, system.out.println, double quotes, the new value of combined fuel consumption, colon, here plus, and new fuel consumption combined, plus, and double quotes again, liter per 100 kilometers or miles. Okay, so if I execute the code now, you can see that everything looks fine. 5 is there, and 15.5 is there too. So from now, we can store bigger and more precise numbers in these variables. Okay, but what happens if we want to do the explicit conversion narrowing? Well, it can be problematic. So let's take power as an example. Let's just say we would like to store it in a byte. So here, byte new power equals power and a semicolon. As you can see, Intellij underlined this whole line. The problem here is that we are missing the casting. We need to specify the type in the case of narrowing in the parentheses. Intellij has a very handy shortcut. So if I take the cursor over the red text here, an option appears, cast to byte. But also if I click on this red bulb here, there are many options appear. There is also, you can see, cast to byte, but there is change variable new power type to short, or change variable power type to byte. So migrate new power type to short or migrate power type to byte. But we're going to choose the first one. And it simply added byte in parentheses. And one more thing here, let's print out the new value. So here, system.out.println, double quotes, the value of the new power here, plus, and new power. And here, plus again, double quotes, and kilowatt. Okay, let's run the code again. As you can see, something went terribly wrong. Here, 106 printed out. However, the original value of power is 362. So what happened here? So Java created a new byte with the value of 0 and started putting in 362. As I told you, the biggest number you can store in a byte is 127, and the smallest one is minus 128. So at the beginning, we are here at 0. Java has just created a variable, new power. Java tries to add the 362 to the new variable, but it reaches the maximum. So it starts off from the smallest value, minus 128. Then it tries to store the remaining 362 minus 128, which is 234, in the new power byte. So we are at the bottom now, and we add 234 to this. And we will get 106 because the remaining 234 plus minus 128 equals 106. So what Java does when you reach the maximum is that it starts the counting from the minimum. The opposite happens when we use subtraction or we use another operation and the result is smaller than the smallest value you can store in that type. So it starts off from the top, the maximum. In real life, byte or short is not used so often. Instead, integer is one of that is preferred. Unfortunately, we can lose data in these type of conversions. So that's why you need to choose your data types very carefully, and you need to pay attention when you use narrowing. Alright, that's all I wanted to share about primitives and conversion. See you in the next lecture. So by now you almost know everything about primitives, and in the next video we will move on to object references. But before that, here is your first practice. I used a used car website in the previous lectures, and here your task would be to choose a website, for example Amazon, IMDb, Facebook, or a game like League of Legends, Counter-Strike, Fortnite, Diablo, or World of Warcraft, or you can choose any kind of application. After this step, create a list of the possible variables and what types you would use to store them. Then create the code where you define those variables, and next, print them out with system.out.println the way I did with Dodge Challenger. And last, after you've finished, share your code with me, and I will get back to you as soon as I can with my feedback. And if you have any questions, feel free to message me. Have a great practice. See you in the next lecture. In this lecture, I'm going to talk about object references. This topic is divided into 4 parts. First, I will tell you what object references are. Second, what makes them different from primitives. Third, what basic built-in object references Java has. And last, we will have a coding part about how we can use them. So, what object reference means? Let me explain this. So, object is an instance of a class. It is stored somewhere in the memory. And reference is used to point to that memory location where that object is stored. You don't have to handle it. Java will do it for you and uses the object name to get the object. To visualize this, you can see a class here. It is like a blueprint, a scheme, a plan for something, like a car, a Dodge Challenger in our case. But it can be a movie, an RPG character, or something else. So here we have this Dodge Challenger class. And it has a lot of attributes like number of seats, horsepower, or is damaged. When you create an object, you can add values to all those attributes. You can have a Dodge Challenger with 392 horsepower, or another one with 707. But you can create many others with different attributes. And you can create almost unlimited amount of objects out of a class. When you create an object, you start the same way as with primitives. But instead of data type, you use a class name. Then the object name equals a value or a new keyword, and then the class name again, next parentheses with some parameters if there is any, and finally a semicolon. As you can see, I use uppercase as a starter letter in the case of the class name. It is not forced by Java, but it is highly recommended because it is the business standard, so it is almost a must. I've mentioned you that you can add parameters, values to the class in the parentheses, and based on that, an object will be created. I will give you more details on this later in the classes lecture. Okay, just to stick to Dodge Challenger, we can create a class Dodge Challenger with all the attributes we coded in the previous lectures. To create an object of the Dodge Challenger class, you need to do the following. So, first the class name, Dodge Challenger, then the object name, red Dodge Challenger, equals, then the new keyword, the class name again, Dodge Challenger, and in the parentheses you can add a color like red and a semicolon. So this line of code is going to create a Dodge Challenger object and its color is going to be red. But with almost the same code, you can create a green one as well. The object name is different. It is called green Dodge Challenger and the parameter is green. As you can see, the class name starts with uppercase. The object name starts with lowercase, as in the case of primitives. Alright then, it was a short introduction to classes and objects. Now let's see what makes them different from primitives. The biggest difference is that they can have functionality. So when we wanted to print out something, we use the println function. And we put the text and variables between the parentheses. In the case of Dodge Challenger, we can create a function like honk. And it would print something on the screen like the green Dodge Challenger honks. Or getColor, which would return the color of the car. Or we can have a getDescription function, and it would return the list of attributes that car has. We can also add functions like turnLeft or getHorsepower. The list of functions you can create is almost unlimited. What you have to keep in mind for now is that you can call these functions when you create an object and you put a dot at the end of the object name. And you can use those functions that are available for that class. But we will go into more details a bit later. Now let's move on to built-in data types that Java has. The list is not going to be unfamiliar for you because every primitive has its object version with a little bit of name change. So byte, short, integer instead of int, long, float, double, Boolean, and character instead of char. The values you can store in them is the same. We also have a new one here, string. String is for storing text like red, green, Dodge Challenger, or sentences. As I mentioned before, objects have useful functions. In the case of string, for example, to uppercase or to lowercase, or equals that can be used to compare two strings. Also, is empty or is blank functions are very useful and they are used quite regularly. But be careful, the last two are not the same. Besides these, there are many other functions that can be called on strings. To define a string is very easy. First, the name of the class, string, then the object name, card type, just like here, equals the text in double quotes, Dodge Challenger SRT 392. String is a bit special because you don't need to use a new keyword here. But string is a big topic and there will be other lectures to cover that. And we're going to also do some coding exercises with string. Okay, I know this lecture has a lot of more on this later part, but I wanted to give you some insight to those Java concepts. I think it's better to give you some insight now instead of not telling you anything or having a separate lecture with a ton of information. Okay, let's turn back to object references. I think the best way we can see how they work, what they are, is to use them in the code. So let's get back to Intellij. Alright, so now we're going to do some coding with object references. So let's create a new class for this. So right click here, new Java class, and let's call it object reference app and enter. Alright, so let's add some space here and let's generate a main function here. We can simply do it. We simply type in PSVM or public static void main. It's a shortcut. And if I hit enter, you can see that the main method is generated for us. So we used the properties of a Dodge Challenger previously. So we will work with that data here too. Now let's create one built-in object reference data type for every single built-in types. So let's start with a byte, so uppercase byte, and then the name, number of seats equals 5 and a semicolon here. Then uppercase short horsepower, a P is missing here, equals 392 and a semicolon. Then instead of int, integer for price, which is 14,999 and a semicolon here. And also let's add a long. So here long registration number equals just random numbers, and at the end an L and a semicolon. Then float with uppercase, fuel consumption combined equals 15.5, and we need to put an F to the end. I'm going to add an uppercase F here and a semicolon. And then a double. So here double fuel consumption precise equals and 15 points, and let's just say a few random numbers, and we don't need to put a letter to the end, just a semicolon here. Okay, so two more types left that have primitive versions. Boolean with uppercase and is damaged equals true, and character instead of char. So here character energy efficiency equals simple quotes, and here a G and a semicolon here, category, this way. So these are the built-in object reference types that have primitive versions. So let's add a string here too. So after these, string car type or model, so here car model equals double quotes and Dodge Challenger SRT 392 and a semicolon here instead of an A, an E. As I said, we can create an object with the new keyword. We can also use it with the string as well. So let's create another object with the same value. So here, string car model and new equals new string, and here let's copy this text and paste it to here and a semicolon. So both gives us the same result, but the first one is simpler. And as you can see, Intellij grayed the new string version. If you take the cursor over the gray area, it says new string is redundant, so it is not necessary. If I click here and I click on the yellow bulb here, you can see that Intellij offers us to replace the new string with the argument. So let's do it. With a simple click, it made the line the same as the one before this. So the second version is not recommended at all with string, but we will use the new keyword a lot with other classes. For now, let's revert the change with Ctrl-Z or Command-Z, just to show you that the same result will be given with both. Now let's print out some of the values. So here, system.out.println SOUT, double quotes, number of seats plus number of seats. Now doubling this line with Ctrl+D or on Mac Command+D. The next one is horsepower. And here instead of number of seats, horsepower. Doubling this line, then the price here, and we add a dollar mark and price. Then the registration number, so doubling this line again, here registration number, and instead of price here, registration number. Here, fuel consumption, and we need the combined, so here combined fuel consumption, and instead of registration number here, fuel consumption combined, doubling this line, and instead of combined we need the precise, and instead of this we need the other one. Is damaged, so here is damaged. This car is damaged, and it will give us true. A few more. So here, energy efficiency category. Okay, and two more. So here system.out.println the car model, and here plus sign car model, doubling this line, and here with new keyword. Car model new. Okay, so if I run the code now, you cannot really see any special here. Okay, but then why we need objects? Okay, so the reason why we would need objects here is, for example, we can have cases when we need the float value of the price, which is a whole number, but sometimes we need to display the decimal part as well, even if it's 0. And on the other hand, we don't want to store a float version and an integer version of the price. So with object references, it's really simple to get the float version of an integer. So after the object name, we just simply need to put a dot after the object name. So here, price dot, and you can see the available function list we can use here. So the function name is on the left and the data type it returns is on the right. We need a function that returns a double or a float, which can be float value or double value. Both can do the job. I'm going to go with float value here. Now let's run the code again. So now the integer appears as a float. You can see an extra .0 there. Okay, now let's print out the integer version of the precise fuel consumption. So going to here and dot, and we need the int value. So if I run the code, you can see that instead of 15 point something, we got 15 simply. So Java chopped off the decimal part and didn't use any rounding, but we got a whole number. So before we finish it, I would like to show you some string functions. So doubling this model line here, and here after the car model, let's use to uppercase. And here with uppercase, and doubling this line again, and instead of uppercase, let's use lowercase, and changing the function name as well. So here, lowercase. Now also, let's see whether the two strings are equal or not. So doubling this line here, and instead of this text, so let's simply type in car model and car model with new keyword are equals, and here car model, and instead of the two lowercase function, let's call the equals function, and here we pass the car model new. Okay, now running the code one more time, and you can see the uppercase and lowercase version of the car model, and here it says the car model and the car model with new keyword are equal. Oh, it's true. So I added an extra letter here. Okay. Alright, that's all I wanted to share about built-in object references. I hope it was clear and useful. See you in the next lecture. In this lecture, I'm going to talk about operators. So why we need operators? Because we need to change the value of the variables somehow, and these signs or operators help us to do the job. Some of them are well known in math, and others might be new to you. And there are operators that are connected to numbers, and others are helping in comparison. So what operators are? By definition, they are used to perform operations on variables and values. But I think it will be more clear if I show you some examples. So this lecture will be divided into 6 parts. The first one will be assignment operators. Second, we will look into arithmetic operators, then honorary operators, and after that, equality and relational operators. Next, Ternary Operator, and last, 2 logical operators. After these, there will be a coding lecture too. Alright, let's start it. So, you have been met the first assignment operator, the equals sign. Nothing special here. There are many other assignment operators, but to understand them, we must go through other operator types first. So we'll get back to here at the end of this lecture. So the next group is the arithmetic operators. So first, the plus sign for addition. Besides numbers, it is also used for strings. Then, subtraction is also a simple one. After that, a not too complicated either multiplication. Okay, the next one is a bit tricky. Division divides the number and returns the whole part of the number. So we use here 2 integers, 5 and 3, and what is returned is 1. So the decimal part is removed. We will get back to this in the coding part. So moving on to the next operator, the remainder. So in the case of the price variable, we divide 5 with 3, and what remained is 2. And that's what will be returned. I know it can be a bit confusing, so let's see some examples of how this operator works. So here you can see the previous example. The value of price is going to be 2. Okay, but why? So here you can see what this operator does. What is on the left is equivalent to the right. So what we do here is that we divide 5 with 3 and it will be 1. And then 1 times 3, and finally we subtract that 3 from 5. So, okay, let's see another example. So here 10% sign 5. The output of this line is going to be 0 because we divide 10 with 5, so there is no remainder. If we use the formula here, 10 divided by 5, which is 2, and we multiply it with 5, which is 10, and 10 minus 10 equals 0. Okay, one more. Here, 13% sign 7. So the result is going to be 6, because if we divide 13 with 7, we will get 1. And after we multiplying that with 7 and subtract it from 13, we will get 6. So what we do here is that we subtract the number on the right from the number on the left as many times as we can. And what remains, and that's why it is called remainder, is returned. Okay, besides these examples, we will also cover this in the coding part. So these operators are commonly used, but there is nothing unusual here except the remainder operator. So moving on to honorary operators. So they have the name honorary because they are not connected to 2 values or variables. They can be used with 1 value or variable. We can use plus sign for numbers, but it won't make a negative value to positive. So basically, it's useless. But minus sign will change a negative value to a positive, like you can see in the example. Then, double plus sign increases the value by 1, and double minus will decrease it by 1. Both can be used before and after the variable or value. And the last one in this group is exclamation mark or invert. It can be used for Booleans to change the true to false or false to true. Alright, that's all I wanted to share in this part. See you in the next one. Okay, so the next group is used to compare variables and the values stored in those variables. And the result of that comparison will be a Boolean. So first, double equals, used to compare two values. So 5 equals 5 will return true. Second, not equals. 5 not equals to 5, and it will return false because 5 equals to 5. So third and fourth, greater than and lesser than. I think I don't have to tell you how they operate. The next two are greater than or equals and less than or equals to. These are also well known in math. And the last one is a bonus, and it is used for data type check. And for example, you can check whether a variable's data type is a string or any other object type. But we will get back to this a bit later. The following group is the Ternary Operator group, which is a one-operator group. It is used in control flows to run different code based on an expression's value. So, variable name equals expression, question mark, value 1, colon, value 2, and a semicolon. So, if the expression is true, value 1 will be assigned to the variable. But if the expression is false, value 2 will be assigned. In the case of the car, damaged text value will be this car is damaged if the is damaged is true. But if the is damaged is false, then damaged text will be this car isn't damaged. Alright, let's move on to the next one. So, logical operators. They have two elements. The first one is the OR operator, two vertical lines. If we have two Boolean expressions and at least one of them is true, the OR operator will return true. Otherwise, it will return false. So, to return false, all the expressions should be false. The other operator in this group is AND operator. And this one will be true if both Boolean expressions are true. So, false and true will return false. And only true and true will return true. So all the expressions must be true to get true. I think it will be much easier to understand it in the coding part. So moving back to the assignment operators. Now you have been introduced to other operators that will be in need for this part. We will use int price equals 5 as a starting value for all the examples. So first, from the new ones, add and equals. It takes the price variable and adds 5 to it and assigns 10 to the price variable. And actually it replaces this form. So basically it's a shortcut for this. It makes our way of coding easier because you don't need to type in price 2 times. Okay, the next one is subtract and equals. It takes price with value 5 and subtracts 5 and assigns 0 to the price variable. And on the right you can see what we can replace with this. Then multiply and equals. 5 is multiplied by 3 and price will be 15 in that case. The following is divide, which does almost the same thing, and at the end the price's value will be 1. And last, the remainder, and at the end price's value will be 2. Okay, so these are using the operators introduced before, but they give you some kind of shortcut. And if it's still not 100% clear, don't worry, there will be also a coding part too. Okay, the last group that I didn't even mention at the beginning is bitwise and bit shift operators, and there is a good reason. These are not commonly used. Maybe I could say, yeah, never. The reason why I still mention them, because the way they wrote is close to other operators. And if you miss, for example, a vertical line from OR operator, you will get a bitwise OR. which won't give you the same result at all. If you miss an AND sign from the double AND operator, you will get a bitwise AND. Then right shift and left shift are similar to greater than and lesser than. And there is also an unassigned right shift. The last two are bitwise complement and bitwise XOR. Okay, as I said, you don't have to know these or waste your time memorizing them. Just keep in mind that Java has such things as well. Alright, that's all I wanted to share here. Now let's move on to the coding part. Okay, so in this coding lecture, we're going to look into a task where we will modify the price of a Dodge Challenger. We're going to go through almost every operator that I introduced you previously. We have a lot of things to be covered, so let's start it. So first of all, let's create a new operators app class. To do that, right-click on one of the files we've already created. I'm going to click on this package here called operators, new Java class, call it operators app. Now we will need a main method here. It can be easily generated with the help of Intellij. So here in the curly braces, PSVM, and if I hit enter, a main method will be generated. Now let's create some variables that we will use here. First, string, let's call it car model, equals, double quotes, and here a semicolon, Dodge Challenger SRT 392. Then int price equals 14,999 and a semicolon. After that, again, int, let's call it money in the bank, equals 100,000 and a semicolon here. And last, a Boolean is damaged equals true and a semicolon here. Alright then, so let's start with the arithmetic operators. These are going to be the easy ones. So let's print out the price first. So here, system.out.println, double quotes, price of A, and here after the double quotes plus, then car model, then plus again, double quotes, colon, and a space, then a euro mark or dollar sign, then plus again, and then price. Now let's create a variable for increased price. Let's call it increased price, but first int increased price equals, and price plus 1,000. And now let's copy this line here and paste it to here. And instead of this price here, let's change it to increased price. And that's also change the text. So here, the increased price of a car model, which is going to be Dodge Challenger. And here we're going to have the increased price. Now, let's create the decreased price as well. So here, copying this, pasting it to here, and instead of increased, decreased. Let's change the text as well. So here, decreased price, and instead of increased price variable here, decreased price. The next one will be 2 cars price. So doubling this again, pasting it to here, and 2 cars price, and here price times 2, and also changing the text, so 2 price, and here 2 cars price. Then let's see how many dodges we can buy from the money we have in the bank. So doubling the code again and changing here the variable name to dodges you can buy, and here money in the bank divided by the price. So now copying this and pasting it to here. So from the money we have in the bank, we can buy, and here let's change it, the order, and deleting this. Let's add a space to here. Okay, and last, let's see how much money we would remain after we use all of our money to buy Dodge Challengers. So doubling these lines again and renaming the variable to money remaining equals money in the bank %, and here price. And let's change the text as well to something like money we would remain after buying, and let's use this dodges you can buy, and here the car model plus, and double quotes again, and colon, and a euro sign plus, and let's use the money remaining variable. Okay, and before we run it, I realized that I didn't change this plus sign to minus. Now let's run our code, and it seems fine. Increased, decreased price, doubled price, and we can buy 6 cars, and 10,006 euros would remain on our bank account if we would buy that 6 cars. All right, that's all I wanted to share here. See you in the next lecture. Okay, now moving on to Honorary Operators. But before that, let's print out a blank line here just to separate the two operators groups. So here, system.out.println, and we left the parentheses empty. Okay, we will create a negative price first. So here, int price negative equals minus 14,999 and a semicolon. First, let's test the plus sign. So int price negative with plus sign equals a plus sign, and then price negative this way. Now let's print out that. So here, system.out.println, double quotes, negative price with plus sign, colon, and then a euro sign. And then after that, plus price negative with plus sign. Okay, the next one is a negative price with a minus. So let's simply copy this here and then pasting it to here. And let's add some space. And here, price negative with, change the plus to minus sign. And then instead of plus here, a minus. And negative price with minus sign, and changing this as well to this. Now let's run the code. So going up here, run. And as I said, plus sign won't change a negative number into a positive, but negative sign will do the job and turns a negative number into a positive. Okay, now let's use the double plus and double minus. They increase and decrease the value by 1. So let's create an int for €1 price increase here. So here, int price €1 price increase equals, and we're going to use the simple price here, so price and then plus plus and a semicolon. Now let's also print that out. So here system.out.println double quotes price after €1 price increase, and then euro sign plus and price €1 price increase. And before we move on, let's run this code. I want to show you something. So as you can see, 14,999 is here, and also our normal price is 14,999. So it didn't increase our price. And you can see this one is yellowed. So it says the value changed at price plus plus is never used. And it is because the price is increased after this evaluation happened. So if we want to increase the price's value before the evaluation, so this way it will give us this 15,000. So this plus sign, if it's after the variable name, the normal price will be evaluated to this price €1 increase. But if we put it before this variable, this price variable, it will be increased before we evaluate it to this variable here. And I just realized that I put this price here 2 times. So let's delete this. And it still works. And let's do the same with the minus. So doubling this line, this whole block, and instead of price €1 increase, we need the decrease, and instead of 2 plus signs, we need 2 minus signs, and changing this variable here to this and the text as well. Okay, now let's run this code. And as you can see, it works fine. So basically what we can see here is that this plus plus price also increased the original price variable's value. So this 15,000 will be evaluated to this price €1 increase, and also changes the value of this price as well. So this variable is going to be 15,000 as well. And with the next line here, this one, this double minus signs, this price will be decreased back to 14,999, and it will be evaluated to this price €1 decrease. And this one is going to be printed out here. Okay, one last operator in this group is the exclamation mark that can change a Boolean value to the opposite value. So it makes a false true and a true to false. So we don't use a separate variable for this. So after this line here, system.out.println, and we can use a shortcut SOUT, and as you can see, Intellij shows us this option, and if I hit enter, a system.out.println will be generated for us, and double quotes there, and here this car is damaged, and colon, and here plus sign, and let's use the is damaged, but before that let's add an exclamation mark here. And before we run it, let's add a blank line as well. So system.out.println SOUT and enter. As you can see, this one is yellowed. Don't worry about it. Intellij shows that we could write there straight false because this is damaged is never changed. So we could simply use false here. But because is damaged is defined with true here, this could be replaced with false because it is going to be false. So let's run the code. And as you can see, this car is, once again. So this car is damaged and it is false now because of this exclamation mark. All right, that's all I wanted to share in this lecture. See you in the next one. Okay. Now moving on to the next group, equality and relational operators. This will be a quick one. So let's start off with a system.out.println here. So SOUT, enter, double quotes, cause, price equals the money in the bank, then a colon, and after that a plus sign. And we are not going to create a new Boolean variable for this, so we will use parentheses, and we need it here. Then price double equals money in the bank. Now doubling this line here and changing this double equals to not equals with the exclamation mark, and the cost price doesn't equal the money in the bank, doubling this line again and changing this to greater than, and the cost price is greater than the money in the bank, doubling this again, lesser than, changing the text, and now doubling these two lines here, copy and paste, and changing this to greater than or equals, or less than or equals, and greater than or equals, or equals. And the last one in this group, our bonus instance of. So car model variable is a string, and to test whether a variable has a certain data type, we can use the instance of operator. So in a new line here, system.out.println, double quotes, the car model variables data type is a string, and here plus and parentheses again, and car model instance of, and simply string. You can see these are yellowed because these are quite fixed, so they are not changing. This price is not changing, not coming from the user, and also money in the bank is also coming from this variable here. And Intellij shows us this whole expression here can be replaced with a false, because this is going to be false. But I want to show you here what these operators does and what they return. Okay, now let's check what this returns and run the code. So here, run. So as you can see, the money in the bank doesn't equal to the car's price. And then the next one returns true. It's actually the opposite of this. And as you can see, the car's price is greater than the money in the bank, which is false, and lesser than is true. And after that, we will get also the same because they are not even close to each other. So false and true here as well. And as you can see, the car's model variable's data type is a string, which is true. Okay, so in this lecture, I would like to show you another group 2, Ternary Operator. This operator takes an expression or a Boolean value, and if it's true, then it does something, and if it's false, then it does another one. So we're going to use the isDamaged Boolean here, and based on that, we will give value to a string damaged text. Okay, so here, after this, and let's close this one here. So string damaged text equals, and now is damaged, and actually it can be an expression as well, like price equals the money in the bank or greater than the money in the bank or something similar, which returns a Boolean value. Okay, now the ternary operator after this is damaged, a question mark, and then double quotes, the car is damaged, then colon, double quotes, the car is not damaged, and here a semicolon. So if the Boolean's value here is true, this text will be evaluated to damaged text. So this car is damaged if this is damaged is true. Otherwise, the car isn't damaged will be the value of this damaged text. So in a new line, let's print out the damaged text. So system.out.println damaged text. And also let's add an empty line here just to separate the two groups, and here as well. So if I run the code now, as you can see, the car is damaged is printed out because is damaged is true up here. But if I change it to false and I run the code again, you can see that now the other text, the car isn't damaged, is printed out. Alright, that's all I wanted to share in this lecture. We still have left two groups. I will introduce them in the next lecture. See you there. Now, moving on to logical operators. So let's copy the Ternary Operators code from here and paste it to here. And let's see whether the deal for 14,999 is good or not. I would say if the car is not damaged or the price is less than 20,000 euros, it's worth seeing the car. Anyways, we shouldn't spend our time inspecting the car. So how we can do it with logical operators? So first, let's change the variable name to worth seeing. So here, worth seeing text. And let's copy this and paste it to here. And now we need to change the is damaged to not damaged with an exclamation mark. So here, an exclamation mark, then or operator, two vertical lines. The price is less than or equals to 20,000. And also let's change the text as well. So here it's worth seeing the car. Let's copy this. Worth seeing the car. Okay, now let's run our code. And it says it's worth seeing the car. It is damaged, which is true, but we use the exclamation mark, so it's false. But the price is less than 20,000, so one of the two expressions is true, and because we have an OR operator, it returned true. And that's why we got this it's worth seeing the car. To get the second text here, both should be false. Now the AND operator. So let's copy the code which belongs to this worth seeing text and paste it to here. And we are going to examine whether it's worth it to repair a damaged car. So let's remove the exclamation mark. And let's change the OR to 2 AND signs. And I would say if the price is below 10,000, it's worth repairing it. So let's change it to 10. And also let's change the text. So instead of seeing, and here as well. And instead of this. And we also need to change the variable name here. So copy this and paste it to here. Now running the code. And based on the price, it is worth seeing the car, but it might be not a good idea to repair it. So we got this text here because the first part here is damaged is true. So it should be true here. But the price is not below this 10,000. So here, one of the expressions, one of the Booleans is false. So this one, and because of that, it returned this. To get the first text, we should have both true. These numbers might not be true in real life, and we would need a lot more details about the condition of the car to make these decisions. I use these numbers here just to show you how OR and AND operators can be used. Okay, so we still have left one group to finish operators. See you in the last one. Okay, now let's move on to our last group, assignment operators. We will use the price variable for this, and its value will be modified in the upcoming code. So to increase the price, we simply need to type in, after these, price plus equals, and 1,000, and a semicolon. In a new line, system.out.println, double quotes, price increased, colon, and then a euro sign, after that plus and price. Now let's double this block here, and instead of plus here, let's use minus and change the 1,000 to 2,000, and here price decreased and the rest remains the same. So we will print out this price variable, and with these steps, the same, this price variable will be modified. All right, so the next one is the double price. So copy this, paste it to here, and instead of minus, this one, and price multiplied, and the rest remains the same. The next one is division. So here, changing this minus to this, and let's change it to 2, and here as well. divided, and with this we will get back, so actually we just expect that we will get back this normal price before we doubled it. And last, let's use the remainder on this price, and so here percentage sign, and instead of 2000 let's use 10, and here remained. Now running the code, so up here, run. So price increase and decrease values are okay. And then we doubled the decreased price. And after that, divided by 2 to get back the decreased price. And last, we used the remainder with the price variable, and we got 3,999. And what remainder does is that it subtracts this 10,000 from this number as many times as possible. And what's left, this 3,999, is assigned to the price variable. So this reminder can cause many confusions, so I also want to show you another example. So if I comment this code out, this one, and I run the code again, and you can see now the price variable's value before we called the remainder, which is 27,998. And as I said before, the remainder operator subtracts this 10,000 here from this 27,998 as many times as possible. And what's left is this 7,998. Okay, I hope it was clear. And that's it. We went through all the operator groups, and I know it was a long one, so take a break if you wish. If something is not clear, feel free to ask, and see you in the next lecture. Okay, so why do we need loops? Because there are many cases when we have to do the same thing again and again and again. When I think of loops, Bart Simpson comes to my mind when he is punished to write the same sentence on the blackboard 100 times. In code, it could be done by copy-pasting the same line 100 times, but I think most of us would miss counting after 30. But it can be done much easier with loops. So what are loops? Loops are repeating code until a specific condition is met. In the case of Bart Simpson, that specific condition is reaching 100 rows. Now let's see what we are going to cover in this lecture. There are a few loop types in Java. First, we will look into the while, then do-while loop. After those, for loop. And finally, I will tell you what and how continue and break keywords can be used. The next lecture will be a coding lecture, and I will give you examples to all of these. Okay, so first let's look into the while loop. It starts with while, then a condition in parentheses, and the code that will be executed repeatedly is in the curly braces. And Java will keep continuing the execution of the code until the condition is true. I think an example will make it more clear. We have to print out being right sucks 100 times. So first we have to define a variable for the loop, strictly outside of it. We will call it I, and its value will be 1. Then the while loop with a condition that should be less than or equals to 100. And the code is in the curly braces. And after we print out the text, we increase the value of I by 1. After the value of I is increased, we get back to while, and Java checks whether the condition is still true. If it's true, it keeps continue executing the code inside the curly braces. When the condition is false, it continues executing the code after the loop. It is really important to keep in mind that the value of I must be modified in the loop. If you don't modify it, the condition will remain true and the code never stops. And we get into an infinite loop. Okay, so this one is a pretty simple example, but later we will use loops for more complex code than just printing out something. Moving on to do while. Its form is a bit different from while. First, the do keyword, then the curly braces with the code, and last we have while keyword with the condition in parentheses. Now let's see the example we used in the case of the while transformed into do while. The biggest difference between while and do while is that while is checking the condition before it starts running it. And if it's true, it will start executing the code. But if it's false, then it will skip the code in the curly braces. Do while runs the code first without any checks and tests after the first code execution is finished. So the code will be executed at least once. After the condition check is finished and it's still true, the execution starts again from the beginning of the do while loop. It's also important to keep an eye on the value of I and don't let the condition be true all the time. Okay, so now moving on to for loop. The form of for loop is the following. For keyword, parentheses, and inside of that, initialization, then semicolon. Next is a condition, semicolon, and an update statement. And last, the code in the curly braces. So let's take our example, which we have used before. It looks like this. For int I equals 1, semicolon, I must be less or equals to 100, semicolon, and I++ and the code. The big advantage here is that we don't have to create a variable outside of the loop, and we don't need to increase the value of I in the loop. But we cannot access to the I variable outside of the loop. It can be used only inside the curly braces. So for loop is much cleaner because we can do all the administration in one line. And it's the best choice if we know how many iterations we have to do. After the code is finished, we get back to the first line of for loop. First, it increases the value of I and then checks the condition. If it's true, it keeps running the code. But if it's false, then it will stop the execution of the loop. An extra thing here is that we can put a loop into another loop. In the case of our example code, the text will be displayed 1,000 times. First, the inner loop will be executed and the text will be printed out 10 times. The value of I will be increased to 2 and the inner loop's code will be executed 10 times again. And it goes on and on and on. You can also have inner loops with while or do while. So we still have two more keywords before the coding part. First one is the continue keyword. It is for skipping steps in the loops. In our example, I use if. I know we haven't talked about it, but I think you can imagine what it does. So the loop goes on, and when the value of I is 10, we skip the 10th print statement. But the loop execution goes along, and at the end 99 lines will be printed out instead of 100 because we skipped at the 10th print. Now the break keyword is for a different purpose. It stops the loop. We use the same code here, but I changed continue to break. So after printing the text 9 times, the loop will be stopped because break will stop the whole loop. So break and continue are not used very often. but there are cases where they are very handy. Alright, that's all I wanted to share here. Now let's continue with the coding part. Alright, so in this coding lecture, we're going to use all the loops we went through in the previous video. First while, then do while, for loop. After that, we will take an example of loop in a loop, and finally continue and break. We're going to use Bart Simpson's punishment as an example. So first, let's create a new class for this. So right-click on one of the files we have created. I'm going to right-click on this package, loops, new Java class, and let's call it loops app, and enter. And let's generate a main method with the Intellij shortcut. So here, bsvm, enter. And now we have a runnable main method. Okay, let's start with while. So as I said, we are going to need a variable outside of the loop. So these variables are called utility variables, and most of the times they have one letter name because they don't have any exact meaning. So they're just helping to run our code 5 or 50 or 100 times. So here, int I equals 1 and a semicolon. Next, a while loop with parentheses. So here, while and parentheses. And in the parentheses, I should less than or equals to. So here, I less than or equals to. And let's use 5 here instead of 100. So here, 5. And after the parentheses, curly braces. And in the curly braces, system.out.println SOUT, double quotes, and here being right socks. Okay, one very important thing here is to increase the value of I every single time. So here, after this, I plus and a semicolon here. I think it would be useful to use I and add it to the text just to see how many lines we printed out. So here, I plus, and here a dot and a space. And also let's print out i's value after the loop. So here system.out.println, double quotes, value of I, and here plus I, and let's add a space. And one more thing, let's add a blank line here, so system.out.println, and that's it. So running the code, and as you can see, being right socks is printed out 5 times. And value of I is 6 because that's when Java stopped the execution of the loop. So 6 made the condition false. Okay, great, it works as it should. Now let's do it with do while loop. So we have to create a new variable for this, and let's call it j. So here int j equals 1 and a semicolon. Starting with do here, then curly braces, and let's copy the code from here and paste it to here. And instead of I here, let's use j, and here as well. And after the curly braces, while, and we got the parentheses, and here we will need a semicolon. And while j is less than or equals to 5. And also let's copy these lines here and paste it to here, and instead of I, let's use j. Okay, running the code again, and it works. We got the same result. So now change the 5 up here and here to 0. And let's run it again. Okay, nice. So as while checks the condition first, and if it's false, Java doesn't execute the loop. In the case of do while, it runs the code first, then checks the condition. So that's why we can see this being right sucks is printed out here. You can leave it as it is, or you can change it back. It's really up to you. Now let's move on to for loop. So we don't need an external variable. So for here, parentheses, and in the parentheses, int I equals 1 and a semicolon. And you can see it's underlined. As the warning message shows, it has been declared outside of the loop here. We used it, we declared it here. So we need another variable name here. So let's call it k. Now k should be less than or equals to 5, then a semicolon again, and k plus plus. And now curly braces. And also doing the same thing, copying this print out line and pasting it to here and changing j to k. Okay, now let's run our code. And as you can see, being right sucks is printed out 5 times with this for loop. Now let's try to print out the case value after this, the for loop. Changing this to k and here as well. And you can see that k is red now. It says cannot resolve k. It's right because k is accessible only inside the loop. So let's delete this line because we cannot get access to k from here. Now let's move on to continue and break. Let's use the fresh and crispy for loop we have just created. And let's add an if statement. So if here, parentheses, k double equals and 3, then curly braces, and in the curly braces let's use continue and a semicolon. Now running the code again, and as you can see the third step is missing as we just expected. Now let's replace the continue with break. And let's run the code again. And as you can see, the execution stopped at the third step and only 2 lines are printed out. Okay, and last, let's do a bit weird thing. Put a loop into another loop. So Intellij also has a shortcut for generating for loops. So if I start typing in here for I and I hit enter, a for loop will be generated with k, even if I type in for I. So in the condition part, let's use here 5, and let's add another loop inside of that. So here for I again, and enter. And this new one is using L as variable name, and let's use here 2. And as you can see, it's a bit different from this. So here k equals 1, but here k equals 0. So let's change this a little bit. So here this, and here equals L equals 1. Now let's copy this line of code here, and let's also add L here. So instead of dot here, let's use double quotes k equals and plus here, then double quotes again, L equals and plus L plus being right sucks. Alright, so if I run the code now, you can see the numbers here, the value of k and l are 1 and 1. Then the inner loop is executed again and the value of l is increased to 2. So the inner loop is running, then the value of k is increased by 1. And the inner loop starts from the beginning. That's why l is 1 again, then 2, and after that k is increased to 3, and l is 1 again. And this goes on and on. So finally, the text is printed out 10 times, which we got because of 5 times 2. Okay, I hope it was clear. We will definitely use loops later for more complex tasks. If you have any questions, feel free to ask. See you in the next lecture. This lecture is about control flow. So when and why we need control flow. There are many cases when you have to act differently based on the user input. Let's take Who Wants to Be a Millionaire as an example. There is a question on every level with 4 options, and only one right answer is there. If the player chooses the right one, the button will start glowing green and can go to the next level. Otherwise, the button will glow orange or red and the player will lose the game. So, based on the decision, different code will be run. So what control flow is? It is used for decision making and it enables your program to conditionally execute code blocks. Okay, what we are going to look into in this lecture. First, the if, then the if-else statements with some examples, and last, the switch statement. After this lecture, there is going to be a coding part too. So how an if statement looks like. First, the if keyword, then a condition in parentheses, then the curly braces with the code. The condition can be a Boolean variable, a comparison, or a complex condition. Let's see some examples. In case of the damaged car, it would look like this. If the car is damaged, we print out damaged car. If the car is not damaged, then nothing is printed out. Another one. If the car's horsepower is greater than 500, the reaction would be, damn, this car is fast. And let's see a bit more complex. If the movie's rating is greater than 6.8 and the movie category is action or comedy, I say I would watch it tonight. The movie's category is parentheses because AND operator has higher precedence than OR operator. Like in math, multiplication has higher precedence than addition or subtraction. Now let's move on to if-else. If-else is an extension of if statement. It gives us a default option if the condition is false. If the condition is true, the code belongs to if will be executed, and after that the execution continues after the whole if-else statement. If the condition is false, then Java executes the code which belongs to else and continue executing the code after that. In the case of is damaged, if the car is damaged, damaged car is printed out, otherwise accident-free text will appear. In the case of horsepower, when the car's horsepower is less than 500, we would get a reaction something like this, well, not that bad. And if the movie's rating is less than 6.8, or it's not an action or comedy, I would say no way to watch it. We also have another form of if-else. In this case, after the first conditional check, we have another check. If the first one is false, then Java checks the second one. If that's false too, then the execution continues after the if-else block. Let's make it clear with an example. In this case, we check the color of the car and we print out the text based on that. If the car's color equals to red, we print out it is a red car. If that's not a red car, we check whether it's a green car. If it's true, it is a green car is printed out. Otherwise, nothing is printed out. We can also add an else option to these. We can have a multiple else ifs here, and at the end we have an else. So in the case of the car color, we can check whether the car is red or green or orange or black. We print out something that shows what's the color of the car and have else for the case we cannot identify the color. If it's not clear, don't worry, we will also cover these in the coding part. Now let's move on to switch statement. So switch is to select one of many code blocks to be executed. Its form is switch keyword, a value in parentheses. We have cases with values that can be compared to the first value. We also have break and default keywords here. Now let's go into details. So the value is compared with the values of each case, like case 1, case 2. If there is a match, the associated block of code is executed. When Java reaches a break keyword, it breaks out of the switch block. This will stop the execution of more code and case testing inside the block. Default part is executed when no case match is found. Let's take the car color again as an example. We give the car color to the switch statement. Java compares it to the cases. If there is a match, the right text is printed out. If there is no match, then I have no idea what the color of this car is printed out. Switch is better in cases when we have a lot of options and the code that belongs to that is quite short, 1 line or 2 lines. In case of more lines, it would make the code less readable. That's it. Let's continue with the coding part. In this lecture, we're going to see some examples to control flow. First, create a class for this too. So right-click, new class, control flow app, enter. Copy a main method from one of the files we have created before. Copy and paste it here. Enter. We're going to need 3 variables. A Boolean is damaged. That will be true. A string, car color, equals purple, and a char, energy efficiency category. Equals simple quotes G and a semicolon. Our first example is using is damaged, so if parentheses is damaged, curly braces, enter, system.out.println, double quotes, damaged car. Now run our code. As you can see, damaged car is printed out. Okay, let's change is damaged to false. Now run our code again. As you can see, nothing is printed out. Now add an else to it. So here, else, curly braces, copy this line, paste it here. Now change the text. Run our code. Now as you can see, accident-free car is printed out. So now instead of printing out nothing, if is damaged is false, accident-free car is printed out. Let's move on to else if now. So if car color dot equals red, curly braces, system.out.println, double quotes, this car is red. Now add an else if, parentheses, car color dot equals double quotes, green, curly braces, system.out.println, copy the text and change the red to green. Now add another one as well, else if car color dot equals blue, curly braces, copy this line and change green to blue. Now run our code, and as you can see, nothing else is printed out than accident-free car. It's pretty obvious because we don't have any condition for purple. So instead of adding a else if car color equals purple, we add an else here, curly braces, copy this line and change the text to I have no idea what's the color of the car. Run the code again. And as you can see, the newly added code that belongs to else is executed. Now let's see an example for switch. We're going to use energy efficiency category here. So switch energy efficiency category, curly braces, enter. Let's just say we are lazy and we want to print out the same text for both A and B category. So case, simple quotes, A, colon, case, simple quotes, B, colon, enter, system.out.println, double quotes, low energy consumption, new line, and the break keyword, and a semicolon. Now let's add another case, G, colon, system.out.println, copy the text, paste it here, and change the text to very high energy consumption, and new line, break, and a semicolon. Now run our code. Okay, so as we expected, very high energy consumption is printed out because we have a G case here. Now let's change the value of energy efficiency category to A. Run our code again. And as you can see, low energy consumption is printed out. Now change it to B. Run it again. So what's happened here? In case of A and B, the same code is printed out. Now change the value to Z. Run our code again. Nothing is printed out now. So our last move here is to add a default block to the switch. So enter, default, colon, and enter again, system.out.println, double quotes, not defined category. Run our code again. So as you can see, because we changed the value to Z, the not defined category text is printed out in the default block. Alright, that's it about control flow. I hope it was clear and useful. If it was not, feel free to ask. See you in the next lecture. Okay, in this lecture we're going to use Who Wants to Be a Millionaire for a programming task. We are not going to use the question that was used in Saturday Night Live comedy show. I cannot pronounce the volcano's name either, neither the name of the cities. By the way, the right answer is A. Now let's move on my question for $1. The question is, who is named as the father of the light bulb? A. Nikola Tesla, B. Marie Curie, C. Thomas Edison, or D. Robert Oppenheimer? Your task here is to create a new class Who Wants to Be a Millionaire app, define a variable with the right answer, print out the question, then your answer. After that, use control flow to decide whether your answer was right or not, and print out something if it was right and another one if you were wrong. I would recommend you to pause the video here and try to do it on your own. Then, if you are finished, start the video again and see how I solved this task. Alright, so we are back to Intellij. Let's create a new class called Who Wants to Be a Millionaire app. So right click, new Java class, Who Wants to Be a Millionaire app, enter, copy a main method from here, paste it here, enter. Now let's define the answer variable. So char answer equals simple quotes and C, because Thomas Edison is the right answer, and a semicolon. Now print out the question. So system.out.println, double quotes, who is named as the inventor of the light bulb. Now print out your answer, double quotes, you marked plus answer, plus double quotes, a dot. Let's see whether you are right. Now the if statement, if answer equals simple quotes C, curly braces, hit enter, system.out.println, double quotes, you were right, you won $1, else system.out.println, sorry, the right answer is Thomas Edison. Thank you for coming. Now run our code. Yay, it's fine. We won $1. It works perfectly. So that's it. If you use switch, that's also a good way to solve it. If you don't understand something here, feel free to ask me. See you in the next lecture. In this lecture, I would like to talk about coding blocks. So why we need coding blocks? Code blocks are used to group together lines of code that has the same purpose. Like in case of switch, we use switch to decide the color of the car and printed out a text based on that. So what coding blocks are? By definition, they are 0 or more statements enclosed in braces, but it can be a for loop, an if statement, a class, or something else with curly braces. We are going to see some details for code blocks and see how variables can be accessed in and outside of a code block. Alright, let's do this. A code block has a starting curly brace and an ending curly brace, and the code that belongs to it is between the braces. We can also have situations when we have a code block in another one. We have a blue and a red here. The red code block ends before the blue one. Let's see a concrete example for this. We can have a for loop with an if statement in it. For loop block wraps the if statement, and the if block is part of the for block. Now let's move on to variable access. The best way to explain this is by using an example. So we have two blocks here, an inner and an outer. If you create a variable outside of the red block, you can still access it in the red block, and you can even modify it. By the end of this code, the number of the owners will be 6. Now let's take another example when you define a variable in the red. So now the number of the owners variable in the red, but we would like to access it outside of the red. The problem is that after the red block is ended, that variable stopped existing. So we get an error if we would like to use that. We call this type of variables local variables. There are other types of variables like class variables that will be covered later in the course. That's all about code blocks. It was a shorter one. Now let's move on to the coding part. So now we are going to do some practice on code blocks. We are not going to create a new class for this. We're going to use the code we created in the control flow coding lecture. Alright, we're going to use the example we used in the previous video. So block starting curly brace, enter, and the ending brace is added. Let's create an inner one too. So starting curly brace and ending curly brace, hit enter here. Now define a number of owners variable, so int number of owners equals 5 and a semicolon. Now in the inner block use double plus sign operator on number of owners and a semicolon, and print out the number of owners after the inner block. So system.out.println double quotes number of owners colon and the space plus sign number of owners. Now run our code. A number of owners 6 is printed out after the not defined category line. Now move the definition of number of owners into the inner block. So delete it from here and paste it here. As you can see, Intellij grayed out the variable name. Take the cursor on the variable name. It says variable number of owners is assigned but never accessed. And if you take the cursor to the line under that, the value changed at number of owners ++ is never used. And also in the printout line, variable name is red. It says cannot resolve symbol number of owners. These are all correct. As I said, the variable was created in the inner block and cannot be accessed after it because they don't exist anymore. If you scroll up and define a variable inside the if block, like string hello equals hello and a semicolon, and you would like to print out hello, system.out.println hello, you get the same error here too. Now revert our changes. So delete it from here, this one here, and move it back here. Alright, that's all I wanted to say about coding blocks for now. I hope it was clear. See you in the next lecture. We have situations when we have to do things repeatedly. For that, we have loops. Alright, but we would like to run code based on different conditions, but we can use control flows for that. And we use methods if we would like to wrap these into a block and reuse it for different purposes. To explain what methods are, I'm going to use an example that my math teacher gave me in primary school. Maybe you have seen something similar. So we had imaginary machine in primary school. The machine had one input and one output, and we had to figure out what the machine does. For example, an input like 5 and we had an output 15. Okay, so what the machine does? It wasn't obvious at the time, but the machine multiplies the number that goes in by 3 and the result comes out. We also had exercises when the machine had 2 inputs and 1 output. 5 and 3 goes in, 15 comes out. And the machine just simply multiplies the 2 numbers. The good thing about these machines is that they can be reused with other numbers and they can just do their job. In Java, you can have machines or methods that have a lot of inputs, or machines that don't have an input or output. It just prints out a text 2 times, or it has an input, but there is no output more than printing out something. By definition, a method or a function is a block of code which only runs when it is called. Functions are one of the most important features of all programming languages. It is very important to understand them and use them the correct way. The takeaway from here is that a method is a block of code that runs only when it is called. They have inputs and outputs, if there is any, and their biggest advantage is that they are reusable. So, what we are going to cover in this lecture. First, we are going to look into how to create a method, then how to call a method. After that, I will tell you more about parameters and arguments, what are the differences, then return values, and finally I will show you what function overloading is and how to do that. After this lecture, there will be a coding part too. Alright, let's do this. Okay, so how we can define a method. First and foremost, it must be declared within a class. The most basic way to define a method is that to start with the data type that the function returns, then the function name, next parentheses, after that curly braces with a return statement. The returned value's data type must match with the return type. The return type can be void, which means that the function doesn't return anything. In that case, we don't need the return statement, just like in the following example. This say good morning function simply prints out good morning. Function definition can be more complex than this. You can add more parameters to definition. Access modifiers can be public, private, or package. We will cover these later in this course. Static shows Java that the function belongs to the class instead of an object. This is also a topic that I will tell you more after you will have knowledge in classes and objects. The return type and the function name have been mentioned previously. Parameters are optional. Parameters are passed and can be used in the functions block. You have already used such functions, for example the main method. The public is an access modifier. Static shows that it belongs to the class. Void, it shows that it doesn't return a value. Main is the function name, then a parentheses. String square brackets shows that it is an array of strings and it is named args. Now let's see a function that's a bit less complex. Get 10% off discount price takes an int price and multiplies it by 0.9 and returns the result. Because we multiply a number by 0.9, we will get a non-whole number, so the return data type is double. One additional thing I would recommend you is that the function should do one thing and its name must tell what the function really does. To call a method in Java, write the method's name first, followed by 2 parentheses with the parameters, if there is any, and a semicolon. In the case of get 10% off discount price, we can use directly 20,000 as an input, or we could use a variable name like price. There are other ways to use it, like assign the output or the return value to a variable. As you can see, the variable's data type matches the function's return data type. You can also use the function as a parameter for any other functions, like in our case for println function. Now let's move on to parameters and arguments. Information can be passed to methods through parameters. They are specified after the function's name, inside the parentheses, and separated with commas. Parameters act as variables inside the method. A method can have an unlimited amount of parameters, but I suggest you not to have more than 3. The following example has a method that takes 2 ints as parameters and returns the discount percentage of the price. Now let's see what's the difference between parameters and arguments. We have a defined function here and a case where we call the function. When a parameter is passed to the method, it is called an argument. So from the example here, int price is a parameter while 20,000 is an argument. Note that when you're working with multiple parameters, the method call must have the same number of arguments as there are parameters, and the arguments must be passed in the same order. Moving on to return values. When you use a function to return a value, the return type must match with the data type of the value that returned. That data type can be anything, a primitive or an object. When your function doesn't return a value, the function must use void instead of a return type. Additionally, there is no return statement in the function, like in the case of say good morning function. Our last topic is overloading. With method overloading, multiply methods can have the same name with different parameters. Why would we need that? Because we can have functions that do the same thing on different data types, and instead of using different names for the same purpose, we use overloading. Okay, this code template for overloading may not make it clearer, so move on to the examples. So here we have the same functions, same definition, same return statement, but the parameters are different. With having just the int version, we couldn't use double or float values, or we should convert them into an int. By having a function with a double parameter, we can use decimal numbers with the same name. Based on the data type we pass to the function, Java will know which function should be called. So that's it. I hope it was clear. If it wasn't, I will try to make it more understandable in the coding part. In this lecture, we're going to see some examples to methods. First, create a new class for these two. So right-click, new Java class, function, app, and hit enter. Now copy a mem method from one of the files you've been created before. Copy and paste it here. Hit enter again. As you see, there is a static keyword in the definition of main method. In Java, there is a rule that static methods can call only other static methods. I will tell you why we have to do this, and I will share more details about the static keyword in a separate lecture later in this course. So we are going to add static to every function we will create here. So first create a function that doesn't have any parameters and it doesn't have a return value. This function is going to print out something like hello or good morning. I will go with hello. So static void say hello, it is the function name, parentheses, curly braces, hit enter here, system.out.println, double quotes, hello. Now run our code. And as you can see, nothing is printed out. Yes, because we didn't call this function. To do that, type in the name of the method in the main method. Just like this. So say hello. And that's it. Now run our code again. And hello is printed out. Moving on to a function that has a parameter, but that still doesn't have a return value. That function is going to use a loop to print out something on the screen based on the parameter it gets. Okay, so static void. Let's call this blackboard punishment. Parentheses and curly braces, and in the parentheses there's going to be a int repeat number. As I said, we're going to use a for loop here. So for int I equals 1 semicolon, I should be less than or equals than repeat number, then a semicolon, I plus plus, and the curly braces, and an enter. The text is printed out, really up to you. I'm going to use being right sucks, so system.out.println double quotes being right sucks. Now call our function in the main method. So blackboard punishment and use 5 as a parameter. Now run our code. And now being right sucks is printed out 5 times after hello. Now I will show you how to create the discount price function with one more parameter. Then I will show you an example of overloading. Alright, start with static, double the return type, the function name get 10% off discount price, parentheses, and an int price as a parameter, then curly braces, enter, and the return statement, return price multiplied by 0.9 and a semicolon. To print out the 10% off price, we're going to use system.out.println function in the main method. So system.out.println double quotes the price with 10% off colon and the space plus and the function name get 10% off, hit enter and use 20,000. Now run our code. And as you can see, 18,000 appeared on the screen. Now let's move on to overloading. Static, double, the function name get discount price, parentheses. The first parameter is int price, comma, then int percent, curly braces, and the return statement, return price multiplied by percent and divided by 100. Intellij yellows out this. Let's see why. So price percent divided by 100, integer division in floating point context. Our code can run this way, but the problem is that in the expression we have integers only, but it should return a double, and an integer divided by another integer would give another integer, and that value would convert it to double at the end. It would lead to weird numbers. To make it work correctly, we have to convert one of our integers to double. The easiest way to convert 100 to double by adding a dot and a 0 to it. And now it's fine. Now move on our last function in this lecture. So static double get discount price. So the function name is the same, parentheses, double price, comma, int %. Curly braces, hit enter, and the return statement, price multiplied by the % and divided by 100 and a semicolon. And as you can see, we have a double in the return statement, the price, so we don't have to convert any of our values into a double. Now let's use the functions we created, and as you can see, they are grayed out because they are not used. So go back to the main method, double this line, change the text to 50% and change the function name to get discount price. Use the int version. We need the second parameter here, which is going to be 50. Now just let's scroll down, and as you can see, the function that uses an int is not grayed out anymore because we're going to use this function and not this one here. Now double this line again. Now let's say it's going to be 40%. Change the value to a double value, which is going to be 0.55, and change the percentage to 60. Okay, now all the functions are yellow. Scroll back and run our code. Everything seems fine. I hope it made clear how functions can be created and how overloading works. If not, feel free to ask. See you in the next lecture. In this practice lecture, your task would be to create two functions. The first one should take a char, the energy efficiency category, and print out the energy consumption of each level by using a switch or if-else. A stands for very low, B is low, C normal, D above normal, E is high, F is very high, and G is extremely high energy consumption. I would suggest you to make the function compatible with lowercase and uppercase char arguments. Also, I would like you to modify the function to return a string and print out the returned string with a system.out.println. The second function should print out a car description, and it should have three parameters: string car model, int production year, and string condition. It can be good, bad, used, or damaged. I also suggest you to pause the video here and try to do these on your own and get back here after you've finished and compare your code to mine. If something is not clear for you or you think you have another solution, feel free to share that with me. Okay, you can create a new class for this task. I'm going to add the two functions to the functions app class we created in the last lecture. Alright, start with static void the function name get energy efficiency, parentheses, char category, curly braces, enter. I'm going to use switch here, so switch, it's going to take the category, curly braces, case, single quotes, uppercase A, and colon. As I said, it should able to take lowercase letters as well, so case, simple quotes, A, and colon. Now system.out.println, double quotes, very low energy consumption, and break, and a semicolon. Now copy these lines, copy and paste it here, and again, and again, and again. Change A to B, then C, then D, then E, F, and last G. Change the text, so it's going to be low, C is normal, D is above normal, E is high, F is very high, and G is extremely high. What is missing here is a default, so default and system.out.println not defined category. Now I'll call the function in the main method, so get energy efficiency and use A as an argument. Now run our code, and the proper text is printed out. Now try with a lowercase, let's see, G, run it again, and it's correct again. Now change the function from void to return a string and print out that string. So scroll back here, change void to string, and instead of system.out.println use return and remove these parentheses. And we don't need break anymore because return ends the execution and the code after that won't be run. So let's change that. And the other cases too. So return, delete this, delete the break as well, return, turn, delete this too, the break, just a few times. And here too. Okay, now scroll back And instead of calling the function, print out the returned value. So system.out.println this. Let's change the argument to b. Now run our code. Alright, so low energy consumption is printed out. The good thing about modifying the function to return a string or any other value is that we can use that return that value for other purposes. Now move on to our second function. So that function should print out a short description of a car, starting with static void get car description parentheses string model comma int production year comma string condition curly braces system.out.println double quotes this car is a plus model. Double this line, change the text. Production year colon. Use the variable production year. Double this line. It is in. Change the variable name to condition plus double quotes space condition. Delete this. Oh, there is a typo. Now call this method at the end of the main method. So get car description. The first parameter is model. I will use Tesla Roadster, comma, production year 2018, comma, condition, it's in good condition. Now run our code again. It seems everything works properly. At the end, I suggest you to create your own version. I hope this lecture was helpful. See you in the next one. In this lecture, I would like to talk about arrays, and first I would like to start with a problem that can be solved with them. So let's just say we have a car, we travel to another country, and we would like to calculate the average fuel consumption. We have the data for every 100 kilometers or miles. If the destination is close, for example 200 kilometers away, we can solve this by using two variables. You add them up and divide them by 2. Easy. Let's just say the destination is 500 kilometers away. Okay, 5 variables, we are still good. And what you're going to do when you have to travel 5,000 kilometers? You should define 50 variables to store that data. That's when arrays can be used. They are like containers. You can store lots of data in them. Okay, so what arrays are? By definition, they are used to store multiple values with the same data type in a single variable. That data type can be anything, a primitive, a built-in object, or a custom object that you created. They can be numbers like fuel consumption, lottery numbers, or text like features of a car or movie titles. But as I said, they store objects like a lot of cars or movies with all the information that belongs to them. Now let's see what we are going to cover in this lecture. First, I will show you how to create an array. Then, what default values are assigned to the elements in an array after creation. Right after that, I will explain array indexing, how to use it to get the data. After that, initialization, then loops for arrays, and finally science fiction, the multidimensional arrays. And as usually, there is going to be a coding part too. One last thing I would like to point out here is that we are not going to go very deep in arrays in this lecture. There will be an advanced level arrays video for that. Alright, let's do this. We're going to use lottery numbers in this lecture as an example. In my country, we have many lottery types. The most popular one is when there are 90 numbers from 1 to 90, and you have to choose 5 and you have to put crosses on them, as you can see on the picture. So how you can create an array that can store the lottery numbers? First, you have to define the data type that will be stored, then square brackets that shows Java, that's not a variable. After that, the array's name, lottery numbers, then equals, new keyword, the data type again, and the size of the array in square brackets, and finally a semicolon. You can also separate the creation and the definition of the size, but you cannot use it until you don't tell Java what's the certain size of the array. The problem with arrays is that you cannot increase or decrease their size. If you know the certain size you will need, they are very good. Later in the course, I will show you what you can use instead of arrays. But now move on to default values. After specifying the size of the array is filled up with default values. In case of integer, it is going to be 0. It is the same for other whole number data types like byte, short, and long. In case of float and double, it is going to be 0.0. For Boolean, it is false. For char has a special character, the null character. You can see the character code on the right. And for object types, it is pretty easy. All object data types default value is null, which means empty object. Be careful, null for objects and null character for char are not the same. Next is array indexing. So we have an array full of zeros. An index is used to select one element of an array. The indexing starts from 0, not 1. Like in the case of lottery numbers, 0 is the first index and the last is 4. Okay, how to use indexes? Let's just say we would like to assign 17 to the first element. To do that, first the array's name, lottery number, the index of the element we would like to use in square brackets, equals, then the value 17 and a semicolon. Now the second one, lottery numbers, 1 in square brackets equals 82 and a semicolon. To use the elements of the array, the formula is almost the same. So to print out one element with system.out.println, use the array's name and the index in square brackets. You can also assign an array's element to another variable, just like this. New number's value is going to be 17 plus 1, 18. You can also override an array element's value the same way as you first assigned value to it. Now let's continue with initialization. When you initialize, you don't have to tell Java what's the size of the array, because you define the elements in curly braces. That will make Java define the size. It can be used when you know the values right at the beginning, and it is very handy because you don't have to bother with the indexes when you assign values. But there are many cases when you have to calculate elements later in the code. Now move on to loops for arrays. The easiest way to go through every element of an array is to use a loop. For loop is one of the best. You start with assigning 0 to I, then in the condition I, it's very important, less than the lottery numbers, and here you can use dot length to get the size or length of the array. And last, I++ as usually. And you can use I as an index, just as you can see in the println function. The for loop prints out every element of the array. There is another type of loop I didn't talk about in the loops lecture. It is called for each. It starts with the for keyword, but in the parentheses, first you define the data type of the elements in the array, then the name you would like to refer to in the code, then colon, and finally the source, the array's name. In the for each loop, you can use the lottery number for one element of the array. You don't have to bother with indexing or length, lesser than or starting with 0. For each is good when you don't need to use the index for any other purposes. You just simply run through the whole array. Moving on to our last topic in this lecture, the multidimensional arrays. In case of lottery numbers, we can store numbers for a week in a simple one-dimensional array. But there are many weeks in a year, it's around 54. Our array for a year filled up with numbers would look like this. The indexing starts from 0 for both columns and rows. So how to create such an array? For multidimensional arrays, you have to use 2 square brackets instead of 1 after the data type, then the array's name equals, then the data type again, and where you have to tell Java the size of the array, you have to specify both sizes. The indexing starts from 0, as I said, so the first element is weekly lottery numbers, square bracket 0, then square bracket 0 again, and its value is 17. The last element is weekly lottery numbers, square brackets 53, then 4 in square brackets. And last, multidimensional arrays can be initialized too. To do that, you have to use different level of curly braces separated by comma. Be careful with this because it is very easy to miss a comma or put a curly brace to the wrong place. That's it for now. We will talk more about arrays later in the course. I hope it was clear. See you in the coding part. In this coding lecture, we're going to use lottery numbers as an example. So first create a new class for this. Right click, new Java class, arrays, app, hit enter. Now copy main method from here, paste it here, hit enter. Now create an array, so int, square brackets, lottery numbers, the array name equals new keyword int, square brackets, 5 and a semicolon. To print out the values in the array, we are going to use a for each loop. So for int lottery number colon lottery numbers, the source, then curly braces, system.out.println lottery number. We didn't assign any values to the elements, so we expect that it will print out zeros. To prove it, run our code, run, and it's correct. Now assign values to the elements, use the array's name, lottery numbers, square brackets, index 0 equals 17, semicolon. Now double this line 4 more times. Change the indexes to 1, 2, 3, and 4. Change the values to random numbers. Just like this. Now run our code again. And now the array is filled up. Our next step is to initialize a multidimensional array that stores the weekly lottery numbers. And instead of 54 weeks, we will use 4 weeks here. Start with int double square brackets. The array's name weekly lottery numbers equals curly braces and a semicolon there. Hit enter here. Another curly brace. Let's just make it simple. So 1, 2, 3, 4, and so on. Now a comma after the first inner curly braces. Double this line a few times. Change the values. Here too. This one too. Just a few random numbers. Alright, and delete this last comma. Alright, we are done with the initialization. Now we're going to use simple for loop to go through the elements. Instead of messing with the definition of a for loop, there is a shortcut in Intellij. If you type in for I here, so for I, and hit enter, Intellij will define almost the whole for loop for you. One thing is missing from here is the condition. So I should be less than weekly lottery numbers dot length. This for loop is going to go through the rows, but we're going to need one for the columns as well. So we're going to need an inner for loop. So for I, hit enter, and as you can see, instead of I, Intellij use J because I has been reserved for the other for loop. Now complete the condition here. So weekly lottery numbers, square brackets, I will show the row that we are currently in, then length. And that's it. Now print out the elements. So system.out.println, but instead of print line, we're going to use the simple print function, which won't put every element in a new line. So weekly lottery numbers, square brackets. The first one is going to be the row, which is I, and the second one is going to be J, then plus, and a space in double quotes for separation. Add system.out.println after the inner loop is ended. So here, okay, the code seems fine. Let's see the result. Run the code. The numbers are good. The format is correct. That's it for now. I hope it was useful and clear. See you in the next lecture.